For this lab report, I will be covering pH curves, specifically titration using pH curves to determine an equivalence point, which will then be used to determine the concentration of an analyte. For context, all sodas nowadays contain an acid of some kind, although the amount of acid present in a can is not provided. These acids range from carbonic acid to citric acid to phosphoric acid. It's important to know how much acid is present in these soft drinks because the acids can weaken the enamel on our teeth, increasing the risk of tooth decay. For my researchable question, I chose to investigate the amount of phosphoric acid present in Coca-Cola. It was essential that I chose a soft drink only containing one acid so that I could collect clear data that I knew targeted the presence of a specific acid. My researchable question is, what concentration of phosphoric acid is present in Coca-Cola? The first method used in this experiment is titration. Titration is an analytical method used to determine the concentration of an unknown solution. This is done by adding a standardized titrant, which is a solution with known concentration, to an analyte, a solution with unknown concentration, until the reaction reaches the equivalence point. In this experiment, the titrant was sodium hydroxide that had a concentration of 0.079 molar, and the analyte was either 20 milliliters or 40 milliliters of Coca-Cola, depending on the trial set. It was important to standardize the NaOH to know the concentration, which will be used in later calculations. NaOH was added to Coca-Cola until the overall pH was around 12. It is important to note that the Coca-Cola was heated until all of the carbonation was gone so that there was no carbon dioxide present in the solution that could interfere with the titration and the pH readings. The second method is using pH curves. After the titration was complete, the pH curve was analyzed to determine the equivalence point. For the first derivative, the equivalence point can be determined by looking at the highest point of the largest peak. For the second derivative, the equivalence point can be determined by looking at where the graph passes through y equals 0. The equivalence point indicates the volume of titrant necessary to completely react with the analyte with no leftover reagents. You can see the regular pH curve, the first derivative, and the second derivative examples on the slide. The final method is calculating the concentration of phosphoric acid. Using the equivalence point calculated from the pH curve, the concentration of NaOH, the analyte volume, and the balanced chemical equation, the concentration of phosphoric acid can be calculated. As an example, I will walk through a sample calculation of trial 1 of the 20 milliliter Coca-Cola trials. For trial 1, the equivalence point was 4.039 milliliters, the NaOH concentration is 0.079 molar, the volume of Coca-Cola was 20 milliliters, and the mole ratio is 1 mole of phosphoric acid for every 3 moles of sodium hydroxide. To calculate the concentration, I multiplied the concentration of sodium hydroxide to the equivalence point volume in liters. This gave me moles of NaOH. I then converted moles of NaOH to moles of phosphoric acid using the mole ratio from the balanced chemical equation. To determine the concentration, I divided this by the volume of analyte in liters, and the concentration was determined to be 0.0053 molar. As for the results, 4 to 5 trials were completed for each volume of Coca-Cola to determine the average concentration of phosphoric acid. The equivalence points for the 20 milliliter trials were determined from the second derivative of the pH curve. As for the 40 milliliter trials, things were complicated a bit by the higher volume. Since phosphoric acid is triprotic, the second derivative wasn't clear enough to be analyzed, and therefore the first derivative was used. It is also important to note that the first trial of the 40 milliliter trial dataset was disregarded in further calculations because it was obvious that there was some source of error. This yielded a higher equivalence point for trial 1 at 10.302 milliliters as compared to the rest of the trials. The removal of this trial was warranted by the fact that the other 4 trials all had similar equivalence point values at around 8 milliliters. Overall, the average concentration of the 20 milliliter Coca-Cola trials was determined to be 0.0054 molar, and the average concentration of the 40 milliliter Coca-Cola trials was determined to be 0.0164 molar. Both data sets also exhibited low deviation values. It is important to note that as the volume of Coca-Cola used increased, so did the average concentration of phosphoric acid. Lastly, for the argument aspect of the lab report, there are 4 key takeaways. First, the 20 milliliter trials exhibited a high level of accuracy and limited error. This is demonstrated by the fact that all of the equivalence point data was around 4 milliliters. Additionally, the standard deviation was 4.33 times 10 to the negative fifth, and the relative standard deviation was 8.17 times 10 to the negative third, both of which are extremely low. This indicates a high level of precision and nearly no random error. For the 40 milliliter trials, there was likely a source of systematic error regarding the higher equivalence point value of 10.302 milliliters for the first trial. It was likely that the Coca Cola was still too warm after being heated, and so the molecules were moving at a higher speed and couldn't react properly with the titrant. However, when this trial was removed from the dataset, the rest of the data was fairly accurate, as all of the data points were around 8 milliliters. There was also a reasonably low standard deviation of 4.29 times 10 to the negative fourth, and relative standard deviation of 2.62 times 10 to the negative second. These values relative to the deviations for the first dataset aren't as precise, but still indicate precision since they are low values. This lower level of precision as compared to the first dataset could be contributed to the fact that only the first derivative could be used to determine the equivalence point, which isn't as accurate as the second derivative, which was used for the first dataset. As for accuracy as a whole, both datasets yield equivalence point values and concentration values that are similar to one another. This indicates that the values have a high level of accuracy. Additionally, as the volume of Coca-Cola doubled, the concentration of phosphoric acid also increased. To be specific, the concentration of phosphoric acid for the 20 milliliter trials was about 0.0054 molar, and the concentration of phosphoric acid for the 40 milliliter trials was about 0.0164 molar. Since the volume and concentration yield a direct correlation, the data sets can be deemed accurate.